engineer for the project system and advanced 3D printed humanoid robot developed by DITAP. He's an active contributor of the open source community and lead writer in top security magazines such as Pentestman eForensics. He is an active reviewer in many reputed journals, including IEEE, Springer, IET, IGI Global, and Hinderway. Currently, he is an associate editor for International Journal of Cognitive Informatics and Natural Intelligence and IGI Global publisher. My heartily welcome, sir.
Yeah, thank you so much, ma'am. Thanks for the introduction. So, shall I start?
Yes, sir. Yes.
Yeah. So, it's really a great time to see all the participants here. So nearly 110. So even in Sundays, it's really shows the energy from the participants. So okay, I thank SRM University for this opportunity, and I am Sivi Chakravarti Seduraman, and I thank Begum ma'am for introducing me. And today's session is completely on Docker, and the agenda of today's session will be like we'll be starting from VM, and we'll emphasize how VM is evolving, and again then we'll be stressing on what are the disadvantage or what are the challenges posed by the VM in terms of deployment, and then we'll move towards Docker, and we'll go with how you can deploy an application in a Docker, and how to push or how to write your YAML file, and how to deploy your Docker instance, and how to pull the Docker images from a Docker hub, and how to deploy it. All these things in this 1.5 hours duration we'll be demonstrating. And along with me, my research students are here. One is Devi Priya ma'am, who is currently pursuing her PhD under my supervision, and another one is Arvind, and who is my undergrad research student. And both of them are very strong in this particular area, whereas Arvind is very strong on DevOps, and he's particularly focused on these DevOps related things. And he'll be starting the session, and due to some urgent meeting, I have to leave the session. I'm really sorry for this, because my other session was already planned before 2 months, and I was halfway in the meeting. I just stopped, and I just want to have an intro, so that's the reason I just came. And my next session on next Sunday on AutoML, I'll be completely delivering. So I'm sorry for today's session. My research students will take over now. So I request Arvind to start with.
Hello, am I audible?
Yeah, Arvind, you're audible.
Okay,
Yes,
sir, thank you.
yes,
So,
yes.
Yeah.
thank you.
So Arvind and Devpriya ma'am, you just start, and if possible, I can join during conclusion, because I don't know whether I can join or not. Even if I'm not joining, you can just conclude and you can wind up. So Sharanya ma'am, I'm dropping the call, and they'll take over the session. Thank you so much.
Okay, sir. Okay.
Yeah, thank you, sir. Thank you so much. Yeah.
Hello, everyone. My name is Arvind Manivannan. Thank you for having me. Today, I will be showing how to deploy and manage VMs in production scale. So this is like a prelude to containerization. If you've ever tried to install a program that is related to ML, and even though you followed the instructions that are available online step by step, and if you're not able to get it running, then it's probably because one of the issues that the solutions that we are going to show now is trying to solve. So this is highly relevant for ML. In fact, in VITAP, we try to run data analytics and ML tools within containers as much as possible to ensure reproducibility. So I will try to share my screen now. Can you see my screen?
Yes, sir. Yes.
Okay, thank you. So today's slides and all relevant resources are available at this link. So if anyone is interested, please feel free to follow along from there. So this is the overview of today's presentation. We will first look at why we virtualize applications when we try to deploy it in production. And then we will, now virtualization I'm sure many of you are already familiar with it using programs like VMware and VirtualBox, but we do it completely different in production because if you've used VirtualBox or VMware, you might have had to click on multiple buttons. And even if it's a VM that you've deployed dozens of times, it is very possible to end up with issues because we might have forgotten to click on some button or some configuration parameter, which cannot happen in production. So we'll be using production grade tools to manage our VMs. So to deploy or to provision resources, we'll be using a tool called Terraform. There are alternatives, but for this session, we'll be looking at Terraform. And then we'll be using another tool called Ansible to configure the VM. So configurations like downloading and installing an application, giving it the proper permissions, configuring the firewall and such. And then now, in production, we're not talking about one or two machines. A single person might be in charge of dozens, 50s, and even hundreds of virtual machines. So it is not possible for one person to log into every single machine and verify the configuration. So we, again, automate the testing process, and we do that with a tool called Test Infra. Now, production demands change, right? Sometimes there will be high traffic, sometimes there will be low traffic, somebody might be running a tool, so we will need new resources. So how do we increase the scale very quickly with the correct configuration that is also tested? That is another thing that we'll be looking at. So to begin with, why virtualization? So if you're using any GNU Linux box, then you might have tried to compile a program or download a program from the internet, and it would have been a simple command to run it, but it may not run because programs are very system specific. When you compile a program, they will get linked to some of the libraries that are on the system that is compiling the program. So there is this library called glibc, which is the C library against which almost every program links to. If you're trying to read a file, trying to reach the internet, trying to write something to std out, your program is linking to glibc. And glibc is very version specific. A program that is compiled on a newer operating system will not run on an older version of the operating system because those APIs simply don't exist in the older version. This particular situation is called dependency hill because you compile and then you ship it to production. It won't run because of dependencies. So dependency hill. So when this problem started becoming rampant, this is around the time when Web 2.0 really took off, the internet bubble was a thing. So at that point, they needed a solution which will solve dependency hill. So the first step towards solving that, or the historically first step towards solving that, was virtualization. When you virtualize, you will be running multiple servers on the same physical server. So why do we virtualize? It is to have dependency isolation, which solves dependency hell, and compute resource efficiency. So in production, you can, if your server has 32 cores, you can project 320 cores out of that. 10x saturation on CPU is very common in virtualization. So if imagine you're trying to run every single program on a separate physical server, you will not have full resource efficiency, right? So with virtualization, you can saturate resources and then get the best out of your hardware. So this will get you reduced operational costs. And since we are not running many physical servers, it also means reduced energy footprint and reproducible environments. Feel free to interrupt me throughout the session if you have any questions. I really don't mind it. So in order to run today's session, we will need the following dependencies, which is any GNU Linux operating system, and KVM, which expands to kernel virtual machine, QEMU, which is an emulator. KVM interlinks with QEMU for some operations. And we need a programmable interface to KVM and QEMU. For that, we use libvirt. Libvirt can talk to multiple hypervisors. So KVM and QEMU are hypervisors. These are the types of software which allow you to run virtual machines. So you can use libvirt to talk to VirtualBox, OpenStack, and there are many hypervisors like that, even Zen. So Terraform uses libvirt to provision resources. And the Terraform is a very specific domain language. With Terraform, you can provision resources on AWS, Google Cloud, Azure. If there is a cloud provider out there, then you can provision resources on it using Terraform. And the next three dependencies are Python based, so we will need Python 3 for it. Ansible is a tool that we'll be using to download and install programs, and Terraform is the testing library that we'll be using to write tests and verify our configuration. Now, we will be using Debian 11 based I'm sorry. Okay, so we'll be using Debian 11 to deploy your app. So it's easier if you have it downloaded rather than downloading it for every single VM. So since this isn't a DevOps specific conference, I will not go into detail about how Terraform and everything works, but rather than clicking buttons, you can define your VM's configuration like this. So this is an 80 gigabyte disk for our VM, and then we have some login configurations. And then we say that our VM has to have 3 GB of memory, 4 vCPUs, some networking configuration. So this is a very DevOps specific. Usually,
Arvind sir.
People working on ML. Yes, sir. Yes, sir.
Little bit volume, please, sir.
Okay.
Okay.
1 second.
Yes, yes.
Am I audible now?
Yes, sir. Yes, yes. It's enough. Okay, okay.
Okay. Thank you. Thank you. So we define our configuration using programming languages, using a programming language, so that, let's say 2 or 3 people are working together, I can come up with this configuration and somebody can verify it for me. And since we are defining it using a programming language, this can be reused. Deploying a new VM is like running this program again. So now we'll try to deploy two. So in this demo, we will be deploying a program called libreddit, which is an application to use Reddit, a social media site. And we will be deploying it in a configuration which which will be running 2 instances of that web app that is load balanced by another instance. So essentially, our topology will have 3 VMs, 2 running the web app and 1 distributing the load across those 2 VMs. To do that, we should first define our deployment configuration. I just showed it, and then we have to run Terraform plan. This will print out what Terraform will be doing on our hypervisors. So this window will show what's happening on our hypervisor. If a new VM is being deployed, it will show up on here. After verifying the configuration, I've already verified this configuration, but I'll do it again really quickly. Login information, we are good. So we will apply our plan now. This will take a couple of minutes. Okay, so like I said, we were deploying 2 web application VMs and 1 load balancing VM. As you can see, it is doing stuff on a VM, so CPU is spiking and then network is also spiking. Okay, so our VMs are deployed. Now, if anyone has deployed VMs on VirtualBox or VMware, you would know how time-consuming it is, right? You'll have to give your credentials and everything. But now our VMs are installed with the configuration that we want, and it's also the user accounts and everything are created. We can verify it by trying to SSH into one of the VMs. It already has my SSH key, so I won't have to enter a password. And we're logged in. So the next thing that we would want to do is install libreddit. If you go to the programs GitHub repository, you'll find installation instructions. We are automating this whole. I'm sorry. check. Okay, screen's not visible. Can you see my screen now? I'm very sorry for that. Okay, thank you.
Arun sir, screen is no issue, but you can increase your voice, sir. Otherwise, you close to mic.
Okay.
Yes.
Am I better now? Is it better?
Now it's okay, sir. Now this volume is okay.
Okay, sir. Thank you.
Yes. Sorry, sir.
So we are going to automate. No problem, sir. Please feel free to interrupt me. So we are going to automate the installation process, and to first show you how it's done. So first we want to get our our VMs to a base configuration. That means installing some basic utilities, configuring the firewall. So we will do that now. So the way Ansible will work is that it will remotely log into our VMs and then run scripts in a certain way. By certain way, what I mean is that it will first verify if that step's end result is already present. If it is present, then it will simply skip that step. If it is not present, then it will run that script and do what its intended result is. So we now have network access to all three VMs. Now let's try to configure it. Now if you look at the network, it will spike in a moment. So now it's running the equivalent of apt update. And now it's installing the programs we need. And there is more activity on the network side. Now, usually data science, machine learning, the programs that that people would normally use for these activities are very popular. So there will be pre-existing scripts for Ansible to do it. So I hope you won't have to manually write these things. It's very easy to write, but it's still something that one will have to learn and then write, which is not fun. Okay, so now we have our base VM configuration. Now we'll try to verify whether it is working or not. To do that, I'm using, okay, we'll get to that step later. Let's now try to configure and deploy libreddit. So what it does is that it will first install Docker on the VM. Since this is a fresh installation, we don't have Docker yet. So it downloads Docker and then installs it, and then it configures our user to access Docker, which is something that you'll have to do if you want to run Docker without sudo. and then it downloads the liberated Docker container and then deploys it. Now, this is not a pure VM demo. Professor Devipriya will be showing how to do Docker specifically, but for ease of use, I've gone with Docker here. We're still installing the Docker program. While that's going on, let's go ahead and configure our load balancing server. So load balancing server is just an Nginx reverse proxy. I'm installing Nginx. So Nginx is installed by the base playbook. So we are installing Nginx, and then we are using a specific configuration which was generated by Terraform to load balance our liberated instance. So let's run that as well. I'm sorry. Okay, so our liberated applications is live. We will, before verifying it with a test suite, we'll try to access this machine by hand. So let it go inventory hosts. So these are the IP addresses of our web application server, and I know that it's running in port 8080. Okay, so liberated is live, and since our load balancer is also configured, if we visit the load balancer's IP on port 80, then we should be able to see it. But the interesting thing about this is that if I open it, if I refresh this now, we should see network activity somewhere. And if I play, I'll find some other video. So we see a network spike here that matches this VM. So our load balancer is working. Now, Nginx by default uses round robin. So if I do the same in this tab, then some other VM's network activity should be spiking. I hope it works. And test our VMs. So like I said, I'm using a library called test infra, and it's very simple to define tests. So we installed these applications in our first playbook. So using test infra, you can test if the package is installed. It's this simple. One does not need advanced Python knowledge to do this. And we verify if basic configuration, like if SSH is working, which is used for remote login, and then if the SSH server and the firewall are configured as intended. And then we use some very application-specific testing, like checking if libreddit is working, is configured properly and working. And then we also test our load balancing servers installation. We verify if Nginx is installed, running properly, and then if our configuration that allows for load balancing is installed on Nginx or not. To do that, it is very simple. So the source code for this demo is available publicly, and it's linked to in the slides. You can take a look at that. I'll be running make commands because the commands are really long and I don't want to waste your time typing it. So when I run a make test, it will automatically run all the tests that we just looked at. And if everything is green, then our server's configuration matches our expectations, which is very important. So now this is configured properly. Now let's say there is an increase in load and you want to deploy a new VM. Now doing that by hand is again very difficult. But here, using something like Terraform, it is as simple as, say, changing a variable. So this variable controls how many VMs we need. So I'm going to bump it to 4. And I'll bring that program in view. So we still have 3 VMs, but soon we will have 5 VMs. So Terraform is stateful. That means that it checks our current installation, see which state it is in currently. So it knows that it only has to deploy 2 more VMs. And that's why we are seeing configuration for 2 VMs only. So after planning, we apply it. So like I said, 2 more VMs are coming into view. I'm not going to install and configure libreddit again because it is time consuming, but I will show how to kill these two VMs and go back to our old state. So this is a very common scenario in production. When there is increased load, you'd want to scale, and then when load subsides, you'd want to scale back. So again, doing that is very simple. We simply reduce that variable back to 2, and then we should have it. And just like that, we are back to our original state. So this is how we manage VMs in production. I'm one person, but within a span of 30 minutes, I was able to fully deploy a production instance of libreddit with load balancing that is all in a reproducible manner. So somebody like me would be able to manage 50s and even hundreds of VMs with a few keystrokes, and that is the power of automation. So like I said, there are some resources at the very end. The source code is available here, and these are the links to tools that we used. And that's it for me. If you have any questions, please feel free to ask them now. Professor Devi Priya will be taking over from here. She'll be showing how to deploy applications on Docker.
And dear participants, if you have any question, please post in the chat box. And Aaron sir, wait for 2 minutes. We're waiting for any questions.
Yes, sir.
And then there is no question, then they will take over the chat.
Okay, sir.
So no problem. Devi Priya ma'am can continue the session. If any question, we will see the last end of the session, sir.
There is one question, sir,
Yes,
I think.
yes.
Okay, sir. Which method is basically used for deploy the virtual machines? So in production, we would be using a tool called Terraform to provision resources. Provisioning resources is telling how much CPU, how much memory and disk space your VM would need. And then we'll be using Ansible to actually download and install the application. I hope that answers your question, madam. Okay, thank you. What are the limitations for virtual machine? Yes, okay. So with virtual machine, we are installing an entire operating system to get dependency isolation. So what operating systems use resources, right? So with as virtualization became more and more popular, and people started noticing this increased resource usage problem, so they were on the lookout for creating cheaper methods to get resource isolation, and that is how containers came to be. With containers, we don't necessarily run the entire operating system. We run a very shimmed down version of it, with which simply means that we bundle the dependencies alone. So background processes of operating system will not be running in a container. At most, you'll have 5 or 6 processes running in a container. So those are the limitations of virtual machine, and those limitations are addressed by containers. Professor Devipriya will explain that in detail. Does that answer your question, sir? Can you? I have another question. Can you please list a few efficient virtual machines for Mac and Windows OS? I am not familiar with Mac OS, but since Mac OS is Unix based, I think most of the hypervisors hypervisor is a software that allows you to run virtual machines, should be able to run on Mac OS. And for Windows, VirtualBox and VMware are popular options. Does that answer your question, ma'am? Okay, thank you. Sir, I think there are no more questions. Can I hand it over to Professor Devipriya?
Yes, sir. Yes, yes.
Okay, sir. Thank you for having me, and thanks everyone.
Thank you, Arvind, sir.
Thank you, Aravind. Sir, I'm sharing my screen.
Yes, ma'am. Visible.
Okay. So now today, hope my screen is visible and I am
Yes.
audible.
Yes, ma'am.
Thank you for the confirmation. So now that you have get an idea about VM and all the related things, now we will see how to create a container and why containers are needed and where and how to use it. So before going into containers, let me give a small introduction about the two technical terms like monolithic architecture and microservice architecture. For that, we can take an example of an e-commerce application where today in this era, we are all familiarized with online shopping, e-commerce business, everything we all are familiarized with. So in this case, no, if you are taking an Amazon website, so you will be generating a request. Based on that, server will provide the responses. In this case, if we are taking the Amazon, there will be customer module, there will be product, there will be cart services, and all these services will be linked together. In the previous years, during the development of this e-commerce application, they have followed the monolithic architecture, where you will be using a single code base for developing all these modules. Like modules, you may be familiar by the term modules. So customer service will be deployed as one module, product service will be deployed as another module, card service will be deployed as another module. Previously, what they did is they have written a single code base for implementing all these modules. And if any change happens, like if I want to change any product or any image related to product, the entire code base have to wait. So that is actually a difficulty while dealing with monolithic architecture. So these are the issues they have faced while dealing with the monolithic architecture, that is large and complex application. Since everything has been included into a single code base, if I want to change any one piece of the code, the entire code has to rebuild. So the complex applications will lead to delay in deploying the applications, and that in turn will lead to slow development and continuous. It also blocks the continuous development. And not only that, if I want to expand the modules, it also have to take more time, and their code has to reschedule. So it is unscalable and it is inflexible. So these are the issues that has been faced in the monolithic architecture while dealing with e-commerce applications. So what they did is for dealing with the delays and all other issues related to the monolithic architecture, they have moved to microservice architecture. In the case of microservice architecture, the same e-commerce application we can take, while the client will request for a service and the same service will be provided. In the case if I am taking for an Amazon website, they will provide the same service but with a faster response time. Why? Because they have developed these things by using a microservice architecture. In the case of a microservice architecture, everything, the same modules will be deployed independently. Like customer service will be having one module which is working independently, while the product microservice product module will be working independently, and likewise cart will be deployed independently. So here what happens is if I want to change any one piece of the code related to the product, then I can only deal with that module. It doesn't directly affect the overall deployment of the product. So thus it increases the response time. So that is there, the delay will be reduced. So these are the features that microservices provide to us. That is independent development. That is each module can be developed without affecting other modules, and that can be deployed also like that. And if any fault occurs in any of the module, then it won't affect the other parts of the module. That is, we can isolate the fault and we can use the mixed technology stack, and it also provides granular scaling. So granular scaling is nothing. It gives a granular control over the performance of our applications. That means we can easily measure the performance so that if any overloaded or overworked things are happening, we can easily measure the performance to find the ones that are performed poorly during the peak demand times. So at a single node, we can differentiate between the monolithic and microservices like this. So in monolithic architecture, we have a single database and a single business logic, which will deal with the entire application. So it will be a singular large computing network with having only one code base that copies all of our business concern. While in the case of microservice architecture, we will be dealing with multiple business logic. It actually is an architecture which is having independent component, and these components run each application process as separate service. So as a result, if anything happens in any one of the module, it won't directly affect the other modules. So these are the companies that you are familiar with that are using microservices in a wide way. Amazon, Netflix, many are familiar to you. Okay, so now we have identified that the delay in the e-commerce application can be reduced by by adopting the microservice architecture as compared to the monolithic architecture. So while dealing with that, then so that is one issue they have dealt, and then one more issue they have faced during the development of the software development cycle is the developer will be. We all know about the software development cycle. So developer will be developing, tester will be testing, and deployment team will be deploying the code. The usual problem or issue that happens while in the cycle is when the developer develops the code, it will work properly and fine in his or her computer. But when the tester uses this, tester doesn't work like if the same code has been run by the tester, they will complain saying that the same code doesn't work on my system. So that is the usual issue previously happened in at the software development cycle. Can you think why? Yeah, as many of you think, the code works in one system and the same code, if it does not work in the other system, then that may be mainly due to the difference in computing environment. That is, as we all suppose if you are teaching the Java program, like Java will be having its own supporting environments like JVM and all those stuff. If that is there in one system and the same components are not available in the system which is running that software, then we can see that it won't work properly. It will show some errors. Because here we can see that all the components and libraries required to run an application should be available in the second system where it is testing. So if this difference happens, then the problem won't work properly. So what could be the solution to this? As previously we have seen, virtual connection can be the solution. And later on, they have used Docker as a better solution. Why? Because In virtual machine model, here we can see that there will be a hypervisor, and in the infrastructure will be overloaded with hypervisor. And then in the virtual machine model, for each application, there will be separate operating systems. While in the case of a containerized application development model, they will provide same operating system, and all the containerized application will be using the same operating system. So we have used the concept of containers, and what is a container that we will see. So now the developer is using containers for developing the application, and the tester will be using the same for running the application. So now, since the container will hold all the dependencies together into a single package, they can run, because all the libraries and applications are embedded into a single package. So there won't be any dependency issues. Then what is a container then? So container can be thought of as, if I am developing an application, I will package my application code along with all the runtime libraries that is needed to run the application, and all the softwares needed to run the application into a single package. So that is called a container. And what is Docker? So we have different types of containers. Out of this, Docker is gaining popularity. And why? Because that we will see in the next slide. And Docker is gaining popularity. And what is it, Docker? Docker is nothing but an open source platform that help to implement this Docker container for the development and deployment of our software. So what are the features that make the Docker popular? The features include lightweight. So why lightweighters? As containers are virtualizing the application, it is lightweight. It doesn't need any separate kernel or separate hardware for that. It is actually virtualizing the application, and it occupies less space. If we are developing a Docker image, it is with less code we can develop a container. And applications run in isolation means they have their own isolation environment. Containers will be running in separate isolation environment, and because of this isolation environment, they are secure, and we can move the containers from one platform to the another platform, and that is why it is portable, and it takes less boot up time, since we are not dealing with any of the hardware for virtualizing the containers. So this is how a container will look like in real world applications. So here we can see that on the left side, we have a Docker engine, and on top of it, we will be deploying the Docker containers. And if I am seeing the first one, Docker container 1, if it is related to an application, for each application, we will be developing a container, and each application will be having its own libraries and its own dependencies. So in this figure on the left side, we have 3 containers: Docker container 1, Docker container 2, and Docker container 3. So we can have multiple Docker containers in a single host. So the same has been implemented with a Docker container in real world applications, where the right side we can see an Apache Tomcat with Java, because if I am running a server in Java, having Apache Tomcat at the server, then I can use this container. So the container 1 will be having all the dependencies associated with that. And second container, if it is related to .NET and SQL Server, and the third container is related to MySQL and Python. So now we have like in short, we can say that containers are nothing but a package which contains everything required for running a particular application. This package contains all the libraries, all the dependencies, all the softwares, right, so that they can run properly from one environment to another environment. So now dealing with the components of the Docker. So Docker will be having, like, if you're dealing with Docker, then you will be familiarized with the components like Docker client and server, Docker images, Docker containers, and Docker registry. So, Docker client and server. The Docker will be running in a client server model. There will be a server who will deal with the request from the Docker client, and the Docker client will interact with the Docker server by using Docker CLI. And then we will be dealing with Docker images. Actually, Docker image is nothing but a template which is used for building a container. It contains all the instructions that is needed, all the libraries, how to download, all the details. It is actually a template which will be used to develop a container. If we are familiarized with programming languages, then template, that is Docker image, will act as a class. Then comes the Docker container. So again, I'm taking the example of a programming language where you will be having a class, and from that class, you will be developing objects. Similarly, you will be having a Docker file or a Docker image. From that, you will be developing containers. So we can say that Docker image will act as a class, and Docker container is an instance of that Docker image. So here numerous Docker containers runs on the same infrastructure, and they share the same operating system if they are implemented on the single host. And each application can run in isolation. Coming to the Docker registry, so we have a registry which is an open source where we can upload our Docker files. Usually the official website of Docker is Docker Hub. We can also use our own public and private repositories, and we can use the commands. We can push the Docker images into the registry, and we can also pull it when and where required. So this is a snapshot of what is the difference between a Docker image and a Docker container. Docker image is containing the configuration of and scripts and all the required things, and that can be moved from one platform to the another platform. It is actually not in the running state. Coming to the Docker container, it is actually the application, and it will run the application in a containerized environment. So now, so thank you. This is what the presentation is. Now we can see how to create a Docker container from a simple Docker image. So for that, I told you about Docker file. So Docker images are written by using Docker file. I'll show you how a Docker file will look like. So this is the overall view. So for creating a Docker container, you should have a Docker image, and Docker image is built on the basis of Docker file. So we need to know how to write a Docker file. So this is how a Docker file will look like. Docker file will be having some set of instructions and set of arguments associated with it. These are the common types of instructions used in Docker files. So you have a left side, if you see, we can have from, run, working directory, copy, and then cmd, expose. All these instructions are there on the left side. And all the, so if I am taking the from instruction, it is mainly used for loading the base image where we can build our application. So here I am using Node 12, and then we have the run command or run instruction. These instructions are executed during the process of building the image and container. So we will see one small example by looking this. Those who are in the initial stage of seeing a Docker file may not be able to understand. So while doing the demo, we will understand that. And then we have working directory. So there is an option in Docker file to set the working directory of the Docker. And then we can copy. So here we have seen a dot and dot. That means we can copy the current directory files into the Docker container environment. So it copies all the local files and directories to the Docker environment. And then again run. We can have multiple run instructions inside a Docker file. And then we have CMD. CMD command is mainly used for what do you say? You can interact with the Docker container through the command prompt. So that also we can use the CMD. Other than the CMD, we can also have volume, user, label. All these instructions are also there. I have used a minimal set of instructions for display purpose. So then we have expose, where we can expose the port. Like a container will be running on separate port and host will be having another port. If we want to expose the container port, we can use the expose command. So now we can go to how to install a Docker engine. For that, you can go to this link. It is available in the Docker docs. I'm copying this, and So you can go to the website like docs.docker.com for installing the Ubuntu. So here we can see the details about how to install the Docker engine. My screen is visible, right? Somebody please respond. Okay. So okay, so now we can go to this site. So those who want to install the Docker engine on your system, you can go to the site like docs.docker.com. It is available in Docker doc site. And here we can find the instructions for installing the Docker engine. So Docker is basically built on Ubuntu, though it support Windows also. But preferably it prefers for Ubuntu based engines only. So to install, if any older versions are there related to Docker engine or conflicting packages are there, you have to uninstall those. And then you should have minimum 4 GB RAM for installing this Docker. So we have, so I am using install apt repository for installing the Docker. You can copy this and paste it in the Ubuntu command prompt itself. And then you have to use this official JPJK, and then you have to set up the repository. So these things you can copy and paste. It won't take much of the time. You can easily copy and paste it. And after that, you have to install the Docker engine. For that, you can use the commands like sudo apt get update and sudo apt get install for installing the latest version. And once everything is done, you can check whether Docker is running or not by using docker run hello world. So here all we can see that the Docker we are using sudo because the Docker will be running in root privilege. So if you want to change that, you can add this username to the doc to the group so that you can run without sudo privilege. So now I am showing you my VMware. Where I have already installed the Docker. Okay, so once I have installed the Docker from the Docker docs, I can check whether my Docker is running properly or not. For that, I will be using the docker run command. So docker run hello world. So hello world has been already installed in my machine, so it won't take much of the time. It will happen in, very fast. So here we can see that when I run the Docker by using docker run hello world, you get a response like hello from Docker. If you are getting a response like this, that means that the Docker has been properly installed in your machine. Okay, so now we will see how to create a Docker file and how to run a container out of it. So before that, if I want to check that if any images are there in your system or not, I can use the command like docker images. So if we type the command like docker images, so here we can see I have already some of the images in my machine. So tag will be there, image ID will be there, created when you created, and all the size and all the details will be there. And if I want to check whether any container is running in my machine or not, I can use the command docker ps-a. So if I type the command like docker ps-a, we can see which all containers are available in my machine. So here I have created some containers already. So it will be detailing the details about the container ID, which is the image from which I have created the container. and what are the commands used inside that, and when it is created, what is the status, and if any ports are mapped between the container and the host, that also will be available. And you can see some of the names, and these names are the names which is allocated by the Docker engine by itself if we are not providing any explicit names for the containers. So here these are the containers available. So now we are going to create a simple Docker file. For that, I am making a directory for FTP, and inside that I will make a files folder, and inside this files folder I will create all my files. Okay, so for every application you have to create a Docker file. I am actually talking from the very basic level of how to create a Docker image. So for that, the Docker file we have to create first of all for creating the image. So the Docker file will be having the name Docker file. Why? Because we have to name the file as DOCKERFILE, where D is capital letter and there won't be any space between these two. This is, I am telling again, I am repeating, this is for the base level. So if I am starting from the base level, you have to create a Docker file, and that Docker file should have the name as Docker file without any extension. So I am opening a Docker file. And inside the Docker file, previously we have seen what all instructions we can include inside that Docker file. So I am starting with from. So from is, we are telling on which base image I have to develop the Docker image. So here I am using Debian as the base image. And inside that I am just giving a cmd command for echoing hello world or hello something. So echo, I am giving hello FTP. Okay, so here I have only used very basic commands, like I am creating my image from the Debian base image, and I am simply putting a hello FTP message. And I can save this. Now I have created a Docker file, and now I am going to build an image from this Docker file. And for building an image from this Docker file, I have to use the command build. So docker build -t, I'm using as first 1.0 dot. So here we can see that I have used the command build. So docker build -t, and I have tagged my image as first and followed by a version 1.0 and then dot. Dot denotes that the Docker file has to be developed from the current directory. So I will put an enter. So here we can see that if it is not already available in my machine, it will take some time to build the image. If it is already there, it won't take much of the time for downloading all the details. So here we have seen what all the things it has performed here. So here we had building the definition from Docker file and exporting the images and all. Now I want to see the, I want to create a container out of this Docker image. So first we will see whether I have created the image or not. So if I check Docker images, so here we can see that first is there and followed by the tag 1.0. Okay, so we have created the image here. Now I will run the image by using the docker run command. For that I am writing docker run, which is the image that I want to run. I want to run the image first 1.0 and then enter. So here we can see that output we get because we have written inside the Docker file as hello FTP. So we have obtained a hello FTP here. And if we check the containers, so docker ps -a will list all the containers. So for the first image, we have created a container here. And what is the command doing is it's simply echoing a hello FTP. So this is how you will create simple Docker image. Now we can see another example where I will be creating a web page and using Nginx server, I will create an container out of it. So for that, I am creating another folder. Web page. So it seems like chat has questions. I will run this also and I will answer that. Okay. So because shifting from my VM machine to that is little difficult for my part. So all the questions will be answered. So for the time being, we will just create a web page and see how it works. So inside that, I am creating a web page and image for a web page and a container out of it. Again, I am writing Docker file. No, I am creating one more files. Inside the files, I will be creating an HTML page. So for that, I am using HTML. This is symbol codes that everybody knows. So nothing more I am adding into it, just to say that hello from web page. Okay. So I have saved this. Now, since I am using Nginx, Nginx is associated with some server configuration. So I am using a default file for the server configuration. For the easiness, I have written already here. So server configuration will be there. Depending on the server, what you want in Nginx, you can copy here. I am using the default configuration here. Pasting this. Saved. So now we can create a Docker file. So inside that, I am telling from, I am using Debian as my base image. And then I am giving another instruction like a label just to label who is the maintainer and all these details. So FDP, it is not mandatory to have this. Create ap.ac.in. Then I am telling the Docker to run the update. So the command associated with this, run apt-get update. And you can use and symbol for updating multiple commands along with the run. You can also use EOF herdoc commands also for run multiple run commands. So here I am using only simple commands. So apt-get, I am installing Nginx. And then, so this command will tell the Docker to update and install Nginx server. And then we have some files, default files, which should be copied to the Nginx server. For that, I am using the copy command. So I am copying default to Nginx sites available. So these are the configuration which has to be deal with while running with Nginx. And again, I am copying index.html also to Nginx. So once this is done, you can expose port. Here I am exposing the port 8080. By default, Nginx will be listening to the port 80. So here, just to demonstrate how the expose port will work, I am using 8080 for that. Then we are running the command for executing the Nginx. So user has been Nginx. So this is for starting the Nginx server. And daemon-off we are using just to tell the Nginx to stay in the foreground, or it will disable the self-demonizing behavior of the Nginx. Okay, and then I am saving this. And then I am going to build an image out from the Docker file. So again, I am using Docker build command. So Docker build -t. So here this is web page. So I am using web page Nginx 1.0, and it should be associated with a dot specifying that the Docker file has to be built from the current directory. So here we can see that if we see okay, 1 minute, please hold on. I am switching my mobile connect. How to get into this? That is another thing. Am I visible now? Hello, am I audible now?
Yes, ma'am.
You are
Okay,
audible.
okay. Thank you for your patience. Okay. So some issue with our Wi-Fi blacklisting us from my software. So I have to move. So I have to show you them. So here, this is the word command I have written. Docker build -t web page nginx 1.0 dot. So here if we see, we can watch all what are the things that is happening here. So we have a docker ignore file that is actually used for while creating the Docker container itself. If we can tell that what all the things we have to ignore, like we have to some files if you want to neglect, then we can tell all these details inside the Docker ignore. And then we can see that here run apt-get -y. This is the command that we are instructing the image to do. So here it will take little time to install the Nginx. So that is what is happening in the background. Okay, it has been successfully executed. So I have written all the commands. The first command is from Debian. It is actually loaded. Then the second command is run apt-get. It is also executed properly. Then we have a copy command and another copy command, which will copy the index.html to the Nginx server index folder. Okay, so now we can run this. So I am running the. So before that, we can see whether I have created my image successfully or not. So if you go to Docker images, so we can see that web page Nginx is successfully created with an image ID. So now we can run this. So Docker run web page Nginx. So before that, I have to specify the port because I have been exposed the port to 8080. Then I'm specifying to run this image so that we can create a container out of it. So now this is running in another terminal. If we see Docker PS, so we can see that this has been running. That is why here we have used only PS instead of PS -a. PS -a will list all the containers which is available in the host machine. So here Docker PS is there, which will tell us which is the currently executing container. So here we have see that a container has been created with from the image web page Nginx using the command, and the port has been mapped here. And since I am not explicitly giving any name to the container, the daemon itself, that is the server itself, will associate a name to it. So we can see that. So now the container is running, and if I take the page, we can see 8080. So this is the Docker file that has been created. Okay, and if I go to so this is how you will create. So if I go to the web browser to see the web page, you can see that hello from the web page. So both sides we have. So thus in the session we have seen how to run simple Docker files, and some of the commands we have familiarized with. These are only the basic commands. Actually, it needs a long time, and in this late night, I am not making you people to listen to this. But now that you have seen how to create a Docker file, how to create, how to see the web page, like if I am creating a web application, how to make it into a container also we have seen. Sir, is time there to show you how to push it into the Docker Hub? Hello, sir.
Yes, ma'am.
Can I show like how to push it into the Docker image also? Actually, I will tell you, okay. Why? Because it won't take much of the time to push it into the Docker Hub. So for inserting into the, so now that I have created a container and I have created an image, I can push this image into the Docker Hub by using the pull command. So for pushing it into the Docker Hub, I have to create an account into it. So I am closing the container for the time being so that I can push the image into the Docker Hub. So for that, I am using Docker login. I have already an account in Docker login. So I am using that for logging into the Docker Hub. Okay, login succeeded. So once I have successfully logged into the Docker Hub, I can push into the Docker Hub using the push command. So for that, you have to tag the image. So I am tagging the image by using Docker tag. Okay. So I have successfully tagged the Docker image. Now I can push this into the Docker Hub. So yeah, for that I am using Docker push. Okay. So this has been pushed to the Docker Hub now. It will take a couple of minutes. It all depends on your network speed. So here we can see that some layers already been pushed. Okay. By the time it has been uploaded in the Docker hub, we will address some of the questions here.